Hello, welcome everybody to this webinar with Han and myself on integrating multiple data sources for meaningful laboratory insight. We hope you'll find it interesting. Just to go into a little bit of background, Han and myself have been working together since 2006. So that's quite a bit of experience together. We've traveled pretty much everywhere on this planet. We've visited multiple different sites, different types of industry, moving from IVF to life sciences to R&D to pharmaceutical production facilities, Middle East, Europe, Asia, the US. So we've got an awful lot of experience. Han is very much the smart one who's done more than myself. So any questions technically will be forwarded to him. All in, I think it's very fair to say that throughout our travels, we've seen the good, we've seen the bad, and we have definitely seen and experienced the downright ugly. So for today, we're going to take you through a little bit of the journey Han and myself have been on since 2006. So hopefully it will make sense. We're going to start with a real life example, that holistic approach that we like, looking and moving on to sensor considerations, introducing the concept of metadata, which is very, very important in analyzing data, future of data, going to the presentation, because if you have a lot of data sources, that doesn't mean you can present them well. So if you have too much information, how do you filter that? How do you manage that data? How do you deal with it day to day, month and month, and how do you deal with that? The future of data analysis is obviously a big key point in this webinar. A lot of buzzwords in the industry like AI and machine learning, but what does it mean practically? Moving to the machine learning, and then we've got hopefully a very interesting conclusion to this webinar. I think, again, consolidating all those years of experience in all the different market segments, and keeping a keen eye on all the developments from cloud hosting, much faster CPUs, EPROMs, and so on, to devices becoming more and more complex, where the world is looking at integration, leading to more data and what to do with it. So, Han?
Thank you, Stephen, for that nice introduction. You make me sound old if we have been working together for so long.
Yeah,
thank you very much. Okay, well, if you look at XiltriX and what we do on a daily basis, we try to use a holistic approach. If you just look at any lab that has a large number of samples, all of them have, for example, -80 freezers. And nowadays, all of these freezers are put together in freezer farms. And what we see happening more and more is that on hotter days, these freezers start to slowly fail. Well, even though the freezers are functioning correctly, they're dissipating a lot of heat. And on multiple occasions, you see that the HVAC system is not performing in a regular fashion. There might not be maintenance done regularly, or there's just downright too many devices crammed in a room that doesn't have enough heat or cooling capacity available. So if you want to do proper monitoring, you want to make sure that you don't have any damage. Just monitoring the temperature of your -80 freezer is not going to be enough. You have to look beyond that. You have to look at your ambient temperatures. You have to look at power failure. You have to look at all kinds of additional parameters in order to be able to actually control your sample stock and to prevent any kind of damage that would occur in cases your AC would fail. Because let's say hypothetically your AC fails, what tools do you still have in your toolbox to do something about it? You can open a door, you can open a window, and in much labs that's not even allowed. But just putting fans in or portable air conditionings is not really appropriate in 2020 anymore. So from this, we need to look at what do you need to do more and what kind of sensor information is going to be appropriate if you want to do more than just the basics. So we've put together a small list of sensors to actually consider when you want to move from this little example into the future. So if we take a look at the next slide, maybe you can take this, Stephen.
Yeah, sure, Han. So it's really funny. I was in a facility last week in the East Coast, and yes, the example of portable EC units was very, very appropriate and not a permanent solution. But looking at these sensors, as you rightly pointed out, Han, it's not good enough anymore to just measure an individual piece of equipment. You need to at least also introduce the factor of the ambient circumstances, being temperature, relative humidity is very, very important, and in understanding the behavior of certain equipments. But it goes quite a bit further. Oxygen is very important, incubators, but also for safety. If you've got bulk tanks of LN2, you need to measure the LN2 either through pressure, level, temperature, vapor phase, liquid phase, light intensity, conductivity, VOCs, and so on. So I think people in a specific facility should open their minds somewhat into getting a good understanding of what is it you would like to understand, or what is it you should have to understand to either improve your science and your facility, or to make sure that it continues working at an optimal level. And that goes to air quality, water quality, stop cycles, and the technology is available to integrate all of that to give you meaningful information. But meaningful information means the introduction of a concept of metadata. So Han, if I can ask you to take the people through this example of just a door sensor.
That's a very good thing. If you look at a fridge and a fridge door is opened, then just from measuring temperature, you're not going to be able to see if the door or if the peak in the graph was caused by a door opening, yes or no, if you're not able to monitor that door opening. So in this specific graph, we've actually demonstrated two incidents where, first of all, a door is open for a certain amount of time, causing the graph temperature to spike. But because you can see that this was one long door opening, you can also retrospectively, during an audit, for example, say, okay, this peak in the graph was caused by a longer door opening, and this was a fault, for example, from a user that opened the door for too long and didn't adhere to the standard operating procedure.
But they never do that.
No, and they never do that, but just look at the second peak, because even if users are adhering to standard operating procedures and are only opening doors for a very short amount of time, but then sequentially, a lot of users don't see each other go in and out of a freezer room or a fridge. So even though they're doing everything right, this temperature buildup after a number of sequential door openings can still give rise to a higher peak than a very long door opening, as you see on the left. So this is a very simple example of, without metadata, you don't have an actual clue why your fridge spiked in temperature. And in order to add any kind of data analysis, this information is imperative. We already recognized this a very long time ago, even back in 2005, as we were doing analysis of the graph that you saw here. A user called us and said, well, we're seeing XiltriX doing very, very strange things, and temperatures are spiking in the middle of the night, even though doors have not been opened. Can you explain to us what this device is doing? And together with the user, we actually analyzed, and this device did not have any door openings, but it turned out that one of the stages, one of the compressors that was cooling this device was failing, and it was failing over a certain amount of days. And because the user actually picked up on this, they were able to source a different freezer on time and prevent the panic situation in the middle of the night when it actually ceased to work. So we early on recognized the fact that if we can do something with this kind of information, we can go beyond just being reactive and become a little bit more proactive. So in order to get there, we need to gather as much data as possible. Yes. So in the next slide, you see how that looks. So
yeah,
that's a lot of data.
It's a lot of data, Han. And coming to my earlier point of all the different sensors people should consider, which are available to be integrated to give you a better and bigger picture. The dark side of that is data fatigue. And data fatigue is very, very much what this graph represents. What are you going to do with too much data, too much information that's unfiltered, unclear. It doesn't give you any useful information as to the interaction of the different data measurements. Sure, you can look at individual lines and say, well, it should be between this and this level. But if you overlay too much information, too much data, it gets confusing. It's impossible to make it useful, pragmatic. At this point, it's not useful to introduce AI and machine learning if you don't understand it yourself. So the data fatigue, I think, is very well expressed like this, and I think some of us recognize this very, very well. But Han, what about data presentation and management?
Yeah, if we look at our customer base, currently we're serving a lot of large pharma sites and large hospital sites, and just the number of sensor points and the amount of information that needs to be presented is running in the thousands and thousands of points that need to be managed by a very small number of people. So in order to make any kind of sense of all of that data, we need to make sure that it is presented well in a powerful platform that has the ability to combine different sources of data, make sure that information is shown in real time. And there is also a quick and easy way to analyze that data. And we need to take into account that in the environments of today, we see a lot of differences in the IT departments. There's a lot of security concerns. And from a perspective of devices, we also see different form factors that have to be taken into account, varying from smaller mobile phones with touch screens to even large television screens and everything in between. So having a powerful platform that can handle all of that is imperative to have people working with the data sets that are gathered by the monitoring systems. But then, even if you have that powerful amount of information in a presentable format, you still need to do something with that. So we want to take a peek into where we go from there into the actual future. And looking at the amount of data available, I think Stephen has a number of thoughts on that.
Yeah, thank you, Han. So when we consider the future of data analysis, I think we need to be very, very realistic into where we stand today, 2020, COVID year, it's still March for sure. But what's the future and where do we stand now? So currently we stand at a point of systems are getting very, very proficient at taking measurements and integrating data and measurements from multiple devices, multiple systems, integrating all of them together. I think that's where we stand today, and that's very, very positive. The next step is, how do you analyze it? What do you base analysis on? A big thing that Han and myself keep coming back to is that experience. Han showed a very wonderful slide dating back to 2005, where, well, it's actually based on experience that we can see what the effect was on that device. So how do you translate that into either an algorithm? Do you want just pattern recognition? How accurate do you want that pattern recognition or the algorithm to be? Are you going to be happy with 90% accuracy, 95, 97, 99? I think 100% accuracy, everybody will understand is pretty much impossible for the foreseeable future at least. But what's kind of that balance between human interaction, people staring at screens, looking at graphs versus, well, we can automate some of this. So I think it will end up, you know, in the very near future being that combination and fine-tuning and adjusting the analysis and the machine learning to that. But then what do you do with those results? The key here is to detect anomalies. When everything goes well, everybody's happy. Good example, you get up in the morning, grab a coffee, get in your car, no lights are on, you're good to go. Bunch of lights come on, that's what you need to know. Your engine fuel is low, there's some kind of erroneous message about engine knock or whatever. You need to detect those anomalies. You need to know what's outside of the norm. So on top of the difficulty of going from measurements, integrated information to the analysis, to the anomaly detection is another huge step where you will find you need to lean on experience. And experience is just king. And I think we realize that in many aspects, you know, of monitoring and EMS systems and VMS and doing your science and knowing your machines, knowing your devices and so on. And it's time to objectify that. So this is my advice to everybody who's listening to this webinar is when you're looking to improve your current system, or you want to replace your system, or you want to add another layer to it, lean on people with experience. They can hold your hand, they can answer a ton of questions you may have, they can have a good rapport with you and have a back-to-back conversation with what's best practices, what's good experience here, what's good experience there, what's overkill, what's a good balance for your facility. Because at the end of the day, what you want to do is improve your facility, get to a much more safe and predictable outcome. And that's kind of the key of what you need to do with analysis, and make it pragmatic, make it useful. So I think, Han, if you want to take us to that machine learning aspect of data.
Yeah, machine learning and also AI are kind of the buzzwords right now. So let's say hypothetically you're looking at a graph of a CO2 incubator. Then over a week, you will see that during the day, during the weekend, and during the night, these graphs will look completely different. If you would put all of that information into machine learning, then machine learning will probably be able to detect a certain pattern. But if you then try to copy that pattern into devices of the same brand within the same lab, you will already see differences. If you're then trying to duplicate those patterns and use them on different devices, different types, different brands, you will see that it's going to be almost impossible to reproduce that. So yes, it's going to be possible to detect certain patterns with machine learning, but because a lot of the sites that we work with have the necessity to adhere to very stringent regulations, reproducibility of all of those machine learning algorithms is going to be key. So if we're not transparent about how the outcome of a certain piece of information was achieved, you're not going to be able to really use that in an effective manner. So it means, going back to what we've shown earlier, we need to know as much as possible about how a device is used, by whom it's used, if it was switched on or off. So going back to that metadata and making sure that that can be used in an actual, in a way that a machine will understand that. So,
and Han, what about validation and machine learning? I mean, there's been difficulties with cloud computing being introduced to some industries versus an on-premise server. What about that? You know, that validation part.
What we see is going to be the future of the machine learning algorithms. So if we go to the next slide. Yep, there we go. Sorry, my microphone was failing. We've put together the 3 most important parts that we will need in order to do any kind of meaningful anomaly detection. And that, first of all, is looking at the measurements. So we've talked about this a lot. We have the real-time measurements that are coming from XiltriX, the real-time information that is going to be put in a large database. But then from that moment on, we need to go to metadata. So
and I think, Han, that's again that key point of just taking single points of data and single sensor points is not enough anymore. You need to overlay and facet and layer all the meaningful information that you can get. And that's coming back to my earlier point of, when you want to upgrade your system, you need to be very cognizant of what's required, what are the options, what are the possibilities, and then get a system to manage that with you, or have an organization that will manage that with you, instead of just laying it all into a machine and hoping for the best outcome, because that's not good enough. Because the analysis is again, and we discussed this a little bit earlier, is that key aspect. So you need very, very accurate measurements. You need a lot of metadata to make more sense of those measurements. And then keep working at the analysis to have meaningful anomaly detection.
And I think the key word is indeed meaningful, because what is meaningful to one lab doesn't necessarily, or isn't necessarily meaningful to another lab. So detecting anomalies is going to be relatively easy, but making them meaningful and also presentable in a format that is usable to a user, and they can actually prevent any kind of damage, do maybe predictive analysis or predictive maintenance, that is going to be a very important and key factor when we move from just doing reactive monitoring into the actual proactive future.
Yep, very much, Han. So I think hopefully everybody's really enjoyed listening to us. So we'll go to the Q&A session next. So thank you very much. And what we like to say is we try to help you sleep at night, which is always very welcome. Thank you, everybody.
Thank you very much, guys.